Thank you, Talia. So today I'm going to talk a little bit about a few things that I've learned in my research on adolescent development behavior, which is a little bit scary in this case because for the first time my subject is actually my audience. So you guys will know when I'm completely wrong, and I hope you don't resent me for it, but maybe we can talk afterwards. Like all content following a clever clickbait title, I won't actually deliver on the promise, but there is a tiny morsel of truth in there. I think that there are some surprising influences on adolescent decision-making. So, what's the problem? We start with what is, from the public health perspective, a paradox in adolescence, and that is that despite this being kind of a peak stage of health in terms of resistance to disease, sort of more resilience to environmental challenges than either adulthood or childhood, adolescents get injuries and die at a 2 to 3 times greater rate than children. So what is going on here? Short answer is behavior. So adolescence has been known for a very long time to be a kind of peak time for risk behavior. This was identified as early as the 1830s by criminologists and what's been known as the age crime curve, which I'll show you here. So you can see this very sharp rise with robbery and burglary arrests from age 10 to 20, and then a quick decline and a kind of steadying out through adulthood. So adolescents are doing some kind of unwise things in the criminal domain. But this extends beyond criminality. And to here we see non-fatal self-inflicted injuries, which has a very similar looking curve. And in this bottom one, a similar kind of shape of behavior for unintentional drownings, which would be hard to explain if you're just trying to think about swimming skill, right? So how do you explain a rise in drownings from age 10 to 20? You'd have to think about a decline in swimming school. So I think it's safe to assume that this has something more to do with kind of risky behavior around water. So how do we explain this kind of spike in risky behavior? The early research on this topic was really focused on the decision-making process, so all the things that go into rational decision-making, like being able to generate your decision options, kind of evaluate the costs and benefits of each of your options, weigh those together, do the sort of mental calculus about what is in your best interest, and then to choose wisely. So cognitive psychologists ran a bunch of tests where they would bring adolescents into a lab and adults into a lab and give them these kind of paper and pencil measures where they needed to rate their vulnerability to each of these kind of consequences and estimate costs and benefits, et cetera, et cetera. And they assumed that they would find some deficit in adolescents that could explain why they would make irrational decisions. So the central question here was, are adolescents actually just incapable of making rational decisions? Well, it turns out through all of these tests that given the same amount of information, adolescents come up with the same choices as adults, or they understand the consequences of risky behavior, so they can understand the probability of contracting HIV after unprotected sex, or getting into an accident if they drive while intoxicated, et cetera, et cetera. The rates of assuming the negative consequences are about the same as adults. And they do not, in fact, suffer from some kind of invulnerability complex where they think that this stuff happens to other people, but just not to them. So there were decades of research that really just kind of ran into a dead end trying to understand what was going on. And so some of the research that I've been involved in has kind of switched, and it's come along with the advent of sort of neuroimaging and other forms of neuroscience that have allowed us to understand more about what's happening in the brain. So this specific question, what's wrong with the teenage mind, was posed by Alison Gopnik in 2012 in the Wall Street Journal. In a kind of review with this clever graphic, trying to think about all the different factors that might contribute to your crazy adolescent. Like, what's wrong with them? Why do they act so ridiculous? I want to change the question a little bit subtly here, but I'm partly prompted by knowing that I was coming forward to talk to a group of adolescents. I want to change the question to what's different about the teenage mind rather than what's wrong. And this reflects my increasingly evolutionary perspective on adolescent development, and that is that there is nothing wrong with the teenage mind. Your mind is perfectly adapted to the developmental stage that you are in. It's not faulty. It's just designed to maybe do different things than what adults are using their minds for. So it reflects this sort of long evolutionary history of your ancestors with these kinds of brains being the most reproductively successful. So you shouldn't, I don't want to disparage your mental capacities. And yet this mind does lead to somewhat riskier behavior. So let's think about some of the functions or the characteristics of adolescent sort of cognition and processing that might contribute to this. So the first thing I want to talk about is this big yellow box that's over the prefrontal cortex, which is pretty aptly placed, actually. And it's called self-control. So this is kind of an umbrella construct used by social and behavioral scientists to talk about a bunch of different things, like the ability to delay gratification, or in the previous talk that we talked about, being able to kind of conceal your facial expressions when you're lying, the ability to persist at tasks, to plan ahead. So we think of it just broadly as a kind of brake system for impulsive behavior. And neuroscientists have studied, cognitive neuroscientists specifically have studied self-control pretty deeply. And we now understand that it relies to a great degree on the functioning of the prefrontal cortex. So this newer frontal part of your brain and its connections to other parts of the brain as well. And with developmental neuroimaging, so studying brain development through these high-resolution MRI scans from childhood into adulthood, we see that there's continuing development of these neural systems all the way well into the late 20s. So these are not complete yet. And so my research has shown that this is reflected in behavior. So we see the same pattern that we see in brain development, and this is just a self-report instrument, but I could show you a lot of other kind of tasks. That self-reported impulse control, so saying that you think before acting, this kind of stuff, increases really kind of slow and steady from age 10 to age 30 in this large sample of like 1,000 people at all these different ages. So this kind of provides one strong clue as to why adolescents might make riskier decisions in some cases. They might just not be able to put the brakes on their behavior. However, this doesn't explain why adolescents would behave more riskily than children, right? So here, the kids, the 10-year-old, should be the most out of control, risky of anyone in the sample, and that's not what we see. And one explanation for why children are not as risky as adolescents is surely opportunity, right? So they're more supervised by their parents. They have less opportunity to go jump off cliffs or drive drunk or whatever it is that we're talking about with risk behavior. But we developmental scientists think there's something else going on as well. Which brings us to the second system, which is the very non-neuroscientific vroom system. And I will relabel that here as a reward-seeking system. So this is also kind of aptly placed in the sort of center middle part of the brain. So these are the oldest parts of the mammalian brain. Include structures like the striatum, the nucleus accumbens. You'll hear about these if you're ever in a neuroscience class. These are the parts of the brain that are very responsible for motivated behavior. So this dopamine signaling can lead you to sort of increase your motivation to pursue rewards in the environment, whether that be food or mating opportunities or just fun, right? So it leads you to go for things. So I think of it as kind of like an accelerator or a go system. It's also the part of the brain that gets hijacked by drugs of abuse. So it can kind of recalibrate that system, which is one of the reasons why developmental scientists are encouraging kids like you to stay away from the hard drugs. So this middle part of your brain doesn't get all out of whack. But that's a tangent. So we see this same kind of pattern of behavior. I'm sorry, going back here. This last part of the last bullet point, powered by the mesolimbic dopamine system, which changes quite significantly with puberty. So there are changes in the receptor density of dopamine neurons. There are changes in the sort of overall functioning of this system that happen, and we don't understand it completely, but we can see it in rodent models, that there are changes in the way this system is functioning right around the time of puberty. So it's not just this slow linear development like I was talking about with the prefrontal cortex, but a kind of non-linear with sudden sort of spike change that happens around the time of puberty. And we see this reflected in behavior too. So these are scores from what we call a sensation-seeking scale. So this is kind of a tendency to pursue exciting, new, thrilling, novel activities. You enjoy going to parties. You enjoy kind of doing new things. You can think of it as like the desire to skydive and jump off cliffs and do sort of fun, thrilling things. There's this increase in reporting of sort of interest in these type of activities in the early part of adolescence, and it kind of peaks in this 12 to 17 range and then slowly declines into adulthood. So this might give some kind of explanation for why there is a jump in risk-taking from childhood to adolescents, why you guys might feel more acutely excited by opportunities for fun in your teenage years. So let's review what we know so far. So we know that in kind of an ideal circumstances, when we give you paper and pencil tests in a quiet laboratory, that adolescents are perfectly capable of making rational decisions. They have all the decision-making machinery there. But we also know that kind of in the real world, your brains are wired to be hypersensitive to opportunities for reward. And at the same time, you maybe don't have fully mature self-control systems, so the ability to put on the brakes when you get into a dangerous situation. So you put these two things together, and you get kind of the terrifying prospect of Justin Bieber in a very fast car, right? So this is the metaphor that's commonly used. It's like starting like a fast car with an unskilled driver behind the wheel. Okay. So there's one more thing, though. This doesn't explain everything. So there's this last pretend brain region that I want to talk about, which is closer to my one weird trick than any of the stuff I've talked about so far, and that is the car surfing region of the brain. So what is this?
Trend. It's called car surfing, riding on the outside of a vehicle while it's moving. A Utah dad now sounding the alarm after his 13-year-old daughter was nearly killed doing it. ABC's Kana Whitworth is here with the story. Good morning to you, Kana.
Lara, good morning to you. So Sydney Keener's father has had enough, and he is using a very scary image to show the world the dangers of car surfing. People are dying doing this, and here's the thing, the car doesn't even have to be going that fast. Experts say moving as slow as 5 miles an hour can have fatal consequences.
It's the disturbing stunt happening more than you think. People surfing on cars. Passengers, even drivers, seen anywhere but inside and buckled in.
So you could consider this a kind of arbitrary example of ridiculous adolescent risk-taking, right? But it illustrates one really important point that I wanted to make, and it's actually more of a question, and that is, do you think that any of these people would actually do this if no one was watching, if they were by themselves? I think it's safe to assume they probably wouldn't, unless there was a video camera set up, maybe, right? So I want to translate this car surfing region into a kind of propensity to take risks when in the company of friends. And this turns out to be a sort of key point in understanding adolescent risk behavior. So let's call this the susceptibility to peer influence, and this idea that adolescents are perhaps more susceptible to peer influence, a kind of peer priming to take risks, is really consistent with a lot of things we know about the developmental psychology of adolescence. First thing we know, adolescence, this is probably the defining characteristic of adolescence, is it is a time of peak sensitivity to the social world, right? So I'm sure you guys can remember this. I remember walking into my 7th grade school for the first day. I'd moved into a new town and like nearly passing out, like just being overwhelmed by the social stimuli so much, like trying to figure out how to navigate the people and who I was going to fit in with, where to sit out at lunch. It's overwhelming, right? So your cognitive and your mental, your emotional resources are all tuned to navigating your social world, like the specific social world of your peers. And that's an adaptive thing, going back to this evolutionary idea. That is the major task of adolescence, is to establish your social identity, to find your people, to find your mates. Like all these kind of things are really key tasks for adolescents. And the data shows this, whether it's ratings or just behavior. We can see it with rats. So rats prefer to spend time in cages with their peers rather than alone, whereas adults kind of show the opposite pattern. So it is a quality that is conserved across species. We also see from those crime statistics that I showed you earlier, if you were to look at the details of those arrests for burglary, for robbery, you would see that almost all of them involved the arrest of a group of adolescents. And when you see the age of the adult crime records, they're almost always arrested alone. So adolescents are committing these crimes in groups. They're often taking these risks in groups. Just like you're not going to, sort of, as an adolescent, most of them don't sit around in a field by themselves, like binge drinking. They'll do it when they're at a keg party, right? I assume. Unless things have changed since I was a kid. I don't know. Another clue here, and this is a sort of a well-established finding that has its own kind of problems in understanding the source of it, but the best predictor for whether your adolescent is going to get involved in risk-taking is if they are hanging out with deviant peers, which just means really other risk-taking peers. So it turns out that saying that you are affiliating with deviant peers is a great predictor of whether you will actually engage in these deviant activities. We don't know which direction that runs in. It could just be that, like, risk-taking kids find each other, or maybe someone's influencing the other person. We don't really know, but we know that there's an aggregation of people around that. So we wanted to study this. We wanted to really see, like, what's going on. Does this have to do with specific kind of influence, or our hypothesis, or the hypothesis of the people that really started this line of research, which is my old graduate advisor in this classic paper? Hypothesis was that just the mere presence of peers, so just having your friends around you for an adolescent, will make you behave in a more risky way, where that won't be the case for adults. So Margot Gardner, who was Lawrence Steinberg's old graduate student, and Steinberg put together this experiment where they recruited groups of 3 people, some of whom were adolescents, some of them young adults like college-age kids, and some of them older, like 25 to 35, to come into the lab and do a series of kind of computer-based risk-taking tasks. The one that I'm going to show data from involved this sort of first-person driving task where you have to decide whether to run through a yellow light or not, and you risk getting into crashes, but you want to get to the end of the course as quickly as possible because you'll get more money, right? So it's just a very basic kind of risk-taking task. And the experimental manipulation that they used was to have each group either complete the task separately in separate rooms, or have one person complete the task while their 2 friends sat next to them. They didn't tell them anything about what they should say to their friends. They just put them in the room and let them take the task. And so here's what they show. So in the alone condition, when everyone is just doing the task alone, there's a number of crashes on the y-axis, and you see that adolescents, young adults, and adults look just exactly the same, right? So there's no difference in risk-taking just when you put these people into their quiet space and have them go through this risk-taking task. But when you measure them with their friends watching, you see a dramatic difference, right? So this red bar, you can see that adolescents take about twice as many risks when their friends are sitting there with them. Young adults, it's about a 50% increase, and adults show no difference at all. So adults just couldn't care less whether their friends are there with them. They're going to complete the task in a cool, kind of rational way. So this sort of shook up the field in only the way that nerdy academics can get shook up, and started a lot of research to dig into this in greater depth. Because now we're seeing, like, wait, this might actually explain something about why adolescents are taking risks. So part of my work as a graduate student was to take this a step further and try to see what the presence of peers, what peers observing your behavior is actually doing to your brain. How is it making your neural function change relative to what's happening with adults? So we kind of repeated the same sort of experimental setup, except of course we couldn't have the friends go into the scanner with them, right, because there's not enough room in there. So we just had the friends on the outside, the kind of scanner control room. And after the one person went into the scanner, we had the friends kind of surprise them by speaking over the intercom and saying that they were going to watch them complete this driving game. And they made some predictions about their performance. So really the only thing different between doing it alone or having your friends watching was just knowing that they were out there watching, right? And so we wanted to see whether that changed their behavior, changed the behavior more for adolescents than for adults, and how that looked in the brain. And we found behavioral results that were just pretty much parallel to what I showed you before, but I want to skip to the brain here. Oh, and I'm sorry, in our brain hypotheses, what we were really interested in is whether this peer observation did one of 2 things. We figured, based on what we knew about the reward system and the self-control system, we assumed that it would either disrupt activity in the frontal cortex, so disrupt kind of self-control, or heighten kind of activity in the reward system. So down there where I'm showing the nucleus accumbens is where we often kind of put the reward system, right in that general area. And the results that we got were a kind of remarkable instance of finding support for a hypothesis. And just pro tip, if you guys go into science, like 90% of the experiments you run won't work. So when you actually do have one that works and supports your hypothesis in a clear way, it's astounding, and it's amazing. It's the best feeling in the world. So we actually found support for our hypothesis. What this shows is that unlike adults, for adolescents, when their friends are watching them while they're getting ready to drive through an intersection or not, this part of their brain, the ventral striatum, it becomes more active than when they're doing the task on their own, whereas adults don't show any difference here at all. So this supported our hypothesis about kind of priming of the reward system. So priming you to go, to kind of like make a little bit more of an impulsive leap. So what do we take out of all this stuff, right? I've got three ideas that I wanted to kind of conclude with. The first is very obvious, very important, but I still think critical, that adolescents are just not the same as adults. You guys know this. We can forget it, though. You look like us, although younger and more beautiful, but you generally are the same size as us. You're very smart. You can reason. You can do amazing things. And yet, in kind of the heat of the moment, your brain doesn't work exactly the same as ours does. And where this becomes important, I think, is not in kind of disparaging you or thinking that you're a menace to society, but it particularly factors into, I think, legal policy. And so we've seen this in the last 10 years or so. We've had a couple of really big Supreme Court decisions that have overturned the death penalty for juveniles and now overturned the ability to have life sentences without parole. And it drew on some of this kind of evidence. Like, in fact, this study was cited in one of them. And just showing that adolescents should not be held to the same level of kind of responsibility, culpability as adults when they make these crimes. They are still a work in progress, right? So that's one big idea, I think. Second, that social context matters quite a bit, right? So the way that you make decisions when you are on your own versus when you're with your friends is going to vary quite a bit. I think there's something that you guys can take out of this for yourselves when you're thinking about it. So when you're trying to plan what you want to do when you go out to a party at night, you've got to remember that you might not be thinking quite as clearly in the moment. And so it's good to try to come up with your plan for how far you will go in certain kind of behaviors before you go, and try to remember that you were thinking clearly when you made that plan, right? And not to change it so much in the moment. And I think we have to take that kind of information into account when we design preventions and interventions. So the big point here, we have all these health education classes. We teach you everything about rates of HIV and all this stuff. It turns out that these health education classes just aren't enough. They haven't shown to be very effective. Like, the DARE program has been an absolute failure in terms of preventing drug abuse. We need to think more about behavior in the moment and not just kind of knowledge. So we need to bring this developmental science into our preventions and help kids build self-regulation skills. Thank you, guys.